Introduces solving a quadratic equation by completing the square. Why you want to complete the square sometimes is if an equation is not factorable, or you want to convert it to vertex form so that you can go out and find that critical point and graph it. So here's an equation, x squared plus 6x minus 16 equals 0. And sometimes these equations aren't factorable. So step one is to take this c term and move it over to the other side. So x squared plus 6x, I'm going to leave some room on purpose and then add 16 to both sides. So that you have your x squared term, your x, and then your constant on the right. Here's where you may just want to pause and listen. You start off by taking half of this middle term. Half of 6 is 3. Then what you do with that 3 is you square it, and you get 9. What you're going to do is you're going to add 9 on the left-hand side. You must also do the same on the right-hand side because you have to balance out that equation. This is completing the square. Now this makes this a nice pretty factor of a perfect square trinomial, and I'll show you why. If you make your chart and you say the factors of c, so the factors of 9 that add to b, which is 6, factors of 9 are 3 times 3 that add to 6. You always get the same number on the left-hand side, a repeated 3. So in factored form, the left-hand side would be x and x, and then plus 3 and plus 3. On the right, we just combine these two terms together. 16 plus 3 is 25. Now I can combine these two parentheses together as x plus 3 all squared, and then 25 on the right. The rest of the problem to solve this is finished by solving by undoing. So to undo solving this equation, we're going to square root both sides. Don't forget the plus or minus. What we're left with on the left is x plus 3. And on the right is plus or minus, the square root of 25 is 5. Last step is subtract 3 from both sides. And you get x equals negative 3 plus or minus 5. So I'm going to break off this equation into two pieces. One, when x equals negative 3 plus 5, and when x equals negative 3 minus 5. Now to simplify those, negative 3 plus 5 is 2, so there's one answer to your quadratic equation, and the other equals negative 3, or negative 8. That's your other answer to your quadratic equation. What those end up becoming are your zeros of your function or your x-intercepts. If you were to graph out this parabola, these would be your x-intercepts. Let's practice with another one. So here's a quadratic equation in standard form. Bring that constant over to the right-hand side. So you have x squared plus 2x equals 7. Leave some room. Take half of the middle term, so half of 2 is 1. Then square that number, and you get 1. So I'm going to add 1 here. I have to balance it out, so I have to add 1 on the right. This makes it factorable. So I split up the x squared as x and x. Now off to the side, I say, what are the factors of c that add to b? So factor 1 that adds to 2. Well, 1 times 1 is 2. So these are the numbers we're going to work with. Plus 1, plus 1. Now I'm going to add these two numbers together on the right. 1 and 7 are 8. Notice, when you do completing the square, you're always going to get the same parentheses. This is called perfect squares. So x plus 7, or x plus 1 times x plus 1 is x plus 1 all squared. Now finish the problem by undoing. So I'm going to square root both sides. Don't forget the plus or minus on the right. When you square root both sides, the left-hand side will cancel out. Now subtract 1 from both sides. And now see if you can break down the square root of 8, which you can. 8 can be rewritten as 2 times 4. And then the square root of 4 is 2. So that 2 is going to come out in front. This 2 will stay underneath. And then you have plus or minus -1. Now we don't want you to enter this into your calculator. Just leave it in exact form. It's still the x-intercepts of the graph. They're just not so nice numbers. And that's how you solve by completing the square.